How did Newton and Leibniz invent calculus? Imagine trying to understand how things change in the world around us. From the motion of planets to the growth of plants, figuring out how quantities shift is a big challenge. That's where calculus comes in. It's a way to describe and analyze continuous change, and it all started in the late 1700s. Two brilliant minds, Isaac Newton and Gottfried Wilhelm Leibniz, each came up with their own methods to solve this puzzle. Their work laid the foundation for a new kind of math that helps us understand the universe better. Isaac Newton began working on his ideas around 1666. He called his approach the method of fluxions. Newton thought of variables as flowing quantities, which he called fluents, and their rates of change as fluxions. His focus was on motion and how things change over time, especially in physics. Newton's ideas were closely tied to the physical world, helping explain planetary movement and gravity. He kept his work mostly to himself at first, only publishing parts of it much later. His most famous book, the Principia Mathematica, came out in 1687 and used calculus concepts to explain how planets move and how objects fall. Interestingly, Newton's notation was different from what we use today, but his ideas were just as powerful. Gottfried Wilhelm Leibniz started working on calculus in the 1770s. He published his first paper on it in 1684. Leibniz was interested in the problem of tangent lines and tiny quantities called infinitesimal, numbers so small they are almost zero but not quite. He created a clear notation system, including the integral sign integral and the differential d, which made calculus easier to write and understand. Leibniz saw calculus as a tool to describe smooth, continuous change in a formal way. His notation is still used today because it's simple and effective, making complex ideas easier to work with. Both Newton and Leibniz discovered that differentiation and integration are connected. Differentiation finds the rate at which something changes, while integration sums up small pieces to find total amounts. This relationship is called the fundamental theorem of calculus. Even though they had different motivations and symbols, their discoveries complemented each other perfectly. Their combined work created the modern calculus we use now. The invention of calculus was a major shift in the history of numbers and math. It opened up new ways to describe how quantities change and grow. Calculus expanded the idea of numbers from fixed points to include dynamic processes. Today, it is essential in physics, engineering, economics, biology, and medicine. It helps us model everything from planetary orbits to population growth. Newton and Leibniz's work made it possible to understand and describe the natural world in a way that was never possible before. Their ideas continue to shape how we see and analyze the universe through numbers and their relationships.